And welcome viewers to the Daily Space Weather. First thing we're looking at is some composite imagery here. Solar Magnetogram and the ultraviolet emissions of ionized iron. New sunspot down here in the southeastern limb means higher likelihood for solar flares. Here's some more views, by the way. This is 211, 193, and 171 angstroms. We're getting a smiley face looking thing going on here. Maybe you can see this. Here's 304 angstroms. This is ionized helium. So we've got a little likely situation here, little higher likelihood of solar flares as a result of this new sunspot group. It's beta class. There still is a large filament hanging out. And the radio flux is only at 80, although it has come up a little bit here. You can see it's flatlined for the past week or so. And this black line is the 10.7 centimeter radio flux. That's hydrogen emissions. All right. So the Space Weather Enthusiast dashboard not showing us any space weather storms currently forecasted. There are some coronal holes about to rotate in. We'll get to it. First, let's look at global seismicity. There is a 7 magnitude earthquake drought continuing here. So when you see an earthquake, realize that it might be a foreshock. Earthquake droughts end in large earthquakes. Let's see what's been shaken over the past 24. Tonga saw a deep quake. It was only a 4.4 magnitude, but nearly 500 kilometers depth. Kuril Islands saw a deep quake at a 4.6. Indonesia saw a deep quake at a 4.7. Did you know that we've got a very high pressure zone actually at the North Pole, the North Magnetic Pole? Yeah, I guess Santa's up there right now under great pressure. I'm not sure if it's because of OSHA mandates or something like that or what the deal is. So Fiji saw some of the biggest quakes of the past 24 hours. There was a 5.2 and a 5.4 at Fiji, one of Earth's shakiest spots, and the deep quake capital of the planet, pretty much right near Fiji, the area north of New Zealand. Very seismically active, and then a 5.6. So let's hope these aren't foreshocks, as that could cause a horrific tsunami if there's a big quake at the surface near Fiji. China saw a 5.0 as well. Also, Japan saw a 5.2, so a bit more seismic activity. And I would remind viewers once again, any of those could be foreshocks, especially during a 7 magnitude earthquake drought. Let's look at volcanoes. While we're talking geophysics, La Palma continues to explode. A little uptick there at La Palma, now a 10,000 foot ash plume on the island volcano. Suwanosejima, flight level 050. Over the Ryukyu Islands, Fuego, exploding. 15,000 foot ash plume over Guatemala. Nevado del Ruiz, we're not sure. Sangay is exploding. Flight level 200. It's a 20,000 foot ash plume over Ecuador. Revenador producing a 15,000 foot ash plume over that same country. The South American nation of Ecuador. Sabancaya, unable to detect, not sure if it's erupting. Nevados de Chilean exploding, 15,000 foot ash plume over central Chile from Nevados de Chilean. Please don't pull Volta Caldera. Please do visit our links, such as smashomash.com. You can find links to our merch there. If you click on the SmAsho merch link, you'll find our merch shop. And the print quality is quite spectacular. If you'd like to put your feet on the face of evil every morning when you get out of the shower, just buy the Fauci bath mat. Yeah, there's a bath mat. You could put your feet on the face of evil. Anyway, today's featured product is Resistance is Fertile. It comes in greeting cards and tote bags and throw pillows and coasters and phone cases and so on. That's our featured product of the day. You can find links once again at smashomash.com. Links below the video, also directly to that site. The ghost magnetometer here of the past couple of days, the past 3 days. Earth is moving into a North Pole current sheet as we make the video, so we might see some jigginess going on with the ghost magnetometer in the coming hours. And here's what we're talking about. Here's the heliospheric current sheet and its polarity. You can see the green current sheet here which is North Pole oriented, moving Earth's way as Earth snaps out of a South Pole oriented current sheet and into a North Pole one. Here's a line of sight view showing the solar magnetogram as well. You can see that blue line dipping way down there toward that new significant beta class sunspot. Here's the coronal hole plot, and you can see trans-equatorial coronal holes associated with the North Pole rotating in. If those remain intact, we can expect some high-speed winds from those. And here's what's going on from the viewpoint of the SDO. And this is actually a 48-hour video. And you can see those South Pole-oriented coronal holes just rotating past the Earth-facing zone as we make the video. Again, that's 2 days of data in 193 angstroms from the Solar Dynamics Observatory. Likelihood of flares goes way up as a result of sunspot 2898. It's a beta class sunspot. That means it has both North and South Pole oriented umbrae, and that makes it much more likely to produce major flares. Don't be surprised an uptick in solar flaring. Here is the solar flaring graph over the past 3 days. That's the GOES 16 and 17. The long and the short of it, the long and the short of the X-ray emissions from the closest star. No spikes in the proton flux, although there is missing data, which does not necessarily mean that Nibiru happened or that NASA is hiding data. There are all kinds of reasons that I won't get into because this is a daily space weather video. Let's go to the real-time solar wind here. Now these yellow bars down here, you see these yellow bars down at the bottom? These are suspect errors because this sort of variation doesn't always happen. You can have communication errors, for example, which can reduce the quality of the data. Anyway, current conditions are showing up at a subsiding of the recent high-speed coronal hole wind streams. This one's currently at 462 kilometers per second, so a little bit elevated there, not to background levels yet. Solar wind density, 6.5 protons per cubic centimeter approximately. So a bit of a subsiding of the high-speed coronal hole wind. Here is the KP index over the past 3 days. You can see it's only at 1 nominal solar wind at the moment. Here's 4 hours of magnetohydrodynamic modeling, the space weather modeling framework. Again, this is the last 4 hours if all is working according to plan. And we're seeing a pretty homogeneous magnetohydrodynamic pressure here out to about 12 Earth radii. That data courtesy University of Michigan. Next, ground magnetic perturbations, changes to Earth's B field on the surface. This is also good at showing you where aurorae are most likely to occur, as well as spikes in induction in the power system. Geospace delta B, changes to Earth's B field. Like the last pane, this is 4 hours of data. We show it daily on our videos, and sometimes we show it additionally if there are geomagnetic storms or unrest going on. We're going to let this play through as it refreshed. Also, consumer tip, we don't edit the videos to get them onto your screen as quickly as possible. Pardon our lateness today. It is indeed a holiday week. Thanks for tuning in and congratulations on realizing that the channel exists. Anyway, there's your other geospace magnetosphere movie. Next, we're going to show you a forecast for the solar system. Here's where heavenly bodies are currently located. There's where they'll be in a week, when we'll have a crescent waning on the first day of December. Next, a star chart. This is what's going on above my head now. We've got the Mars and Mercury. We've got the Mars and the Moon. We've got the Moon and Mars and Mercury up there, near to the Sun on the ecliptic. That's in-the-sky.org. Let's take a look at our coronal mass ejection watch here. We don't always show this, but it looks like things have largely calmed down. So we're going to reduce our coronal mass ejection warning to a watch. Nothing to write home about there. Next, a brief cosmology segment. Today's random number is 91, which is a high-mass X-ray binary at the Neil Gehrels Swift-Bat X-ray Observatory. If you scroll down to entry number 91, you'll find this, LSI plus 61303. This is a gamma-ray source and a candidate for all sorts of exotic names. Whether you think it's a black hole or a microquasar or a massive object orbiting a less massive object, I don't really care what your theory is about it. These are the X-rays from it. So this is X-ray at the Neil Gehrels Swift-Bat X-ray Observatory. Let's take a look at this thing visually. Oh, by the way, it's believed to be a microquasar, a binary system. Basically, it's a star with a more massive star orbiting it, or something on those lines. It does have some dark spots in its spectra. Let's check it out. Here it is on the CDS portal. And if you look at the photometric points, you can see it's dark in some wavelengths and very bright in others. And it is indeed a gamma ray source. This is an optical from the XMM Newton. It's located at about 6,000 light years estimated distance to this high-mass X-ray binary. And here's one of the many gamma ray wavelengths that you can look at. This is from one of the Fermi surveys, and you can see it is a very, very bright gamma ray source. Here it is in X-ray on the XMM Newton. Let's don't forget the Chandra. And you can see a bit of an oblong appearance to that. Perhaps there's a huge plasma disk out there that's all emitting X-ray. We don't often see that elliptical shape in X-ray emissions. And here it is on the Galix. This is ultraviolet. You can see it's a quite bright ultraviolet source with a little blob there associated with it. Here it is optically on the Pan-STAR survey, bands Z and G. And here is this, quote, microquasar and, quote, in infrared spectra. It's the heat emissions as measured by the 2 mass. And again, that object is known as LSI plus 61303. Entry number 91 at the Neil Gehrels. Today's astronomy picture of the day is the Seven Sisters. And thanks to everybody who stargazes on our channel. Cheers, congratulations on realizing we exist. Make sure you check out our cosmology segments. We've got over 200 videos in the playlist. And those are not daily space weather videos. Those are our cosmology segments. This is the astronomy picture of the day. You can go check it out yourself at apod.nasa.gov. The Seven Sisters, the Pleiades, a local, massive star cluster of blue stars. And the Earth could be related, the Sun could be related to those Seven Sisters. Perhaps it's got some similar ancestors. I'll just say that. We don't note any charging hazards, but we may be seeing some electron flux warnings coming. Here's the one-year chart of the electron flux. Yeah, electrons have the ability to charge up the surfaces of satellites when there are essentially too many electrons there. Too much charge builds up on the surface. It can cause communications failures. And you can see we've just moved into warning territory here while we were shooting the video. Let's blast this thing out and get through some more data. And shout out once again to the SMASH team. Relativistic electrons here. You can see the forecast is for even higher levels. We may see some communications breakdowns as a result of that. Let's hope not. Tomorrow's Thanksgiving. Here is your Van Allen belt diagram. Because we're showing you the total electron content forecast, you can see significant GPS errors over large parts of the U.S. Large parts of the U.S. Large parts of the U.S. are going to see GPS errors. Next, here is the diagram of the ionosphere to show you where the F layer is. It's at about 300 kilometers of altitude. Don't be F'd. Watch our videos daily if you want to know what's going on in the ionosphere or all kinds of other aspects of space weather. We have them in an order for a reason. What you're looking at here is vibrational frequency at 300 kilometers of altitude. And next, the anomalygram. And you can see low frequency anomalies over large portions of the planet. Also, some high frequency anomalies indicating a large shift. And let's bring up the latest image here. There it is. That's very late today, 13:30 Universal Time. Again, there's the ionogram. And there is the anomalygram showing you low frequency anomalies in red, high frequency anomalies in blue. All right, we've got bonus features. The first is the ground-based solar observatory at Cerro Tololo, Chile. Not Philly, Chile. Cerro Tololo, Chile. You can see massive filaments in the southern hemisphere here. Those dark regions, those are absorption features, where they are blocking the emission of hydrogen at 6,562.8 angstroms. Next, your colorized magnetogram and your freshly refreshed solar intensitygram. And that sunspot, it's still growing, it looks like. Here are the fields. Don't be surprised to see some solar flares. What about the NASA GOES 16 SUVI imagery? And some website technical difficulties there have got us closing out the video with a 48-hour SDO video in 94 angstroms to show the entire formation of that new sunspot. Thanks again for tuning in, and may that solar wind be at your back.